Good day, viewers. My name is Darlington Okoka, and I welcome you to the Delwit Electrical YouTube channel. Today, we shall be discussing on how to choose the right inverter for your building. As we know, renewable energy is becoming the order of the day. In this part of the world, in Africa and some other regions where they have epileptic power supply, it's usually because of epileptic power supply. But in the advanced world, it's as a result of greenhouse effect trying to control making going green to ensure that we don't burn diesel, we don't burn gas, we don't burn fuel that will deplete the ozone layer. So people are trying to ensure that we go green in the nearest future. But in Africa, ours is just to ensure that we don't have epileptic power supply. So inverter systems is one of the major reasons, the major ways by which we have constant power supply. So what's an inverter? An inverter is a form of an uninterrupted power supply, UPS. It has an input that is connected to mains, either the public power supply or the generating system, which is used, it accepts it as a DC, but it has a rectifier within the circuit that converts it to a DC that is used to charge your battery. So when the batteries are being charged, by the time you have a power failure, the battery now supplies the inverter. The inverter now inverts the DC to AC, which is being used to supply your buildings. So how do you know the right inverter to use for your building? In this episode, we shall be discussing on just the sizing and the type of your inverter system. In subsequent sessions, we'll be talking about the sizing of the battery, we'll be talking about the sizing of the solar panel, we'll be talking about the sizing of the charge controllers, and every other component that has to do with a complete solar system installation together with the inverter system. So for the inverter system now, the four basic requirements that you have to know before knowing that, oh, this is the inverter I'm going to buy are one, power requirement. And you need to know the power requirement, your load requirement of the building. This is very, very important. The second one is the VA rating of the inverter. So after knowing the power requirement, then you use that power requirement to calculate your VA rating, which is volt amps rating. The third one is to know the phase. You need to know the phase. If you are going to use a single phase, you are going to use a three-phase. It's very important because if your load is a three-phase load or you have a three-phase load in your building and you don't have, if you are using a single-phase inverter, obviously it's not going to carry your load. So you should know if you are going to be using a single-phase or a three-phase inverter system. They're available in the market. So, but what you need to do, just identify your type of load and use it to carry out your installation. Then the last one we're going to talk about is the output waveform. Now, depend on your load. If you have a very, very sensitive load, your waveform is supposed to be a complete sine wave, a pure sine wave. But if you don't have a sensitive load, you could use the modified sine wave or you could use the square wave. So let's look at the basic calculation on what to do within the three instances. So for us to do a power rating, let's take an example of a building that needs to be powered. You have 510-watt LED bulbs, you have two 32 inches television sets, you have two laptops, and three ceiling fans. All these are the load that you want the inverter to power. So let's look at it this way. For your LED bulbs, you have 10 watts, and there are 5 of them. So 10 times 5 is 50 watts. Your 32-inch television, most 32-inch television, if you check the ratings for LED, is 150 watts. So you have 2 of them, you multiply it by 2, that's 300 watts. So, but I advise, don't assume that your 32 inches television is 150 watts. Look at the nameplate on your TV to know the appropriate rating of that TV set. The third one is your laptop. Most laptops are 90 watts. So when there are two laptops that you want to power. So 90 times 2, that is 180 watts. Ceiling fans too. Ceiling fans are usually 70 watts, but check your own to know the rating. So then there are 3 ceiling fans. So 70 times 3, which is 210. Therefore, the total wattage that is required will now be your LED bulb, which is 5, is 50, your 32 inches 300, your laptop 180, your ceiling fans 210. So 50 plus 300 plus 180 plus 210 will give you 740 watts. So this is your power requirement for your building. So with this power requirement, that is what you use to go to the second option, which is the VA rating of the inverter. Now with your power requirement, your VA rating is the voltage amps rating, which is usually what is used to rate every inverter system. But it's advisable that you don't load your inverter to 100%. I said it, you don't rate it to 100%. So usually we have what we call an efficiency of every inverter system, which in power system we call it the power factor. So most inverters are usually between 60 to 90% efficiency. So this efficiency, you have to know, you have to take note of it when you are buying. So you know the higher the efficiency of the inverter, the better the output is going to give to you. So if you look at it, if it's 60, if it's 70, if it's 80, you would know. You use it for your calculation. So let's assume that you are going to be using an 80% efficiency inverter system. So whenever you are going to the market, from your calculation, you've already assumed that my calculation is 80%. So any inverter that has 60, any inverter that has 70, and everything, so it's going to be from 80 and above. So if you see that of 90, better for you. So now, from your calculation, if you look at your screen, you will see that you have VA is equal to power requirement over efficiency of the inverter. VA, which is the rating of the inverter, is equal to power requirement or the total load of the appliances over the efficiency of the inverter. So we've said that our power requirement from our previous calculation is 740. And we have assumed that the efficiency of the inverter we want to purchase is 80%. 80% is 0.8. So from our calculation now, our VA rating of the inverter will now be equal to 740 over 0.8. When you do that, you have 925 VA. So with the calculation, you can see that it's 1000 VA that can carry this load of the building. So when you have a load of 5 10-watt LED bulbs, you have two 32 inches television sets, 2 laptops, and 3 ceiling fans, and an approximate of 1 kVA inverter, which is 1000 VA, will be able to power this load. The third point we're going to be talking about is the output waveform. On the screen, we're going to be showing you 3 output waveforms. The first one is the square wave. The square wave inverter system is one that is very simple and cheap. The design is very, very easy and is suitable for low sensitive appliances or equipment, such as just lighting or heating load. So if you have that and you don't have the resources, you could just go for the square wave inverter. So that's the kind of wave, and most equipment are usually sinusoidal, they're not in square. So it's not advised stable. Most times it's being phased away now. You rarely find a square wave in the market. But for those of people that want power supply for lighting and you don't have enough capital, you could go for the square wave inverter. So with this square wave inverter, it's also rated in kVA. So you could actually get 500 VA square wave inverter. You can also have 1 kVA square wave inverter. That is if you are going for a less sensitive appliance. The second one is modified sine wave. Now from our graph, you will see that the modified sine wave is also squared, but with space in between. Squared, but with space in between. So with that space is in between them shows that it's positive half cycle, negative half cycle, then a small space between them. So it has a total harmonic distortion of approximately 45%. So if you are not also considering a very sensitive load too, you could also use this. This also can be used from some kind of sinusoidal load. So modified sine wave, if you don't have money for the pure sine wave, you could go for modified sine wave. And if you are not using audio equipment like the TV or radio stations, you could use that are very, very sensitive to sound and harmonics. You could use modified sine wave for your inverter system. But the most appropriate inverter system that is required in every system is the pure sine wave. The pure sine wave has a 3% GHD, total harmonic distortion. 3%, just 3%. That is to tell you how effective a pure sine wave is. So most in the market now, what you normally see is the pure sine wave inverter system. So as I advise, if you have the resources, go for a pure sine wave. So if you look at the graph, you see that it's a pure sinusoidal wave, and most equipment work with this sinusoidal is AC. All your alternating current is sinusoidal in nature. So all your equipment are already built in to appreciate or to function effectively with the sinusoidal nature of the AC current. So I advise that we should all go for a pure sine wave inverter. Then the last one we're talking about is the phase. Now we have single phase and we have three phase. So depending on your kind of load, will determine the type of inverter. So if all the load in your house is using a single phase, so why spend the resources to buy a three-phase inverter? Because usually three-phase inverters are more expensive than a single phase. But if you have a three-phase equipment, it's advisable you buy that of a three-phase inverter. So I believe I've been able to educate you on how to choose the right inverter for your buildings. We've talked about 4 major points which I advise that you take into consideration before buying your inverter system. You have to take into consideration your power requirement of your building. You have to take into consideration the VA rating of the type of inverter you want to buy. You have to also consider the output waveform that is required. If you want a square, you have a modified sine wave or a sine wave. And you also have to take into consideration the phase. If you're going to use a single phase, you are going to use a three phase. I believe I've been able to educate you. If you have, kindly click on the subscription button to subscribe to our channel so as to get notified when subsequent videos are being posted in our channel. Thank you for coming to our channel.